we're going to talk about normal distribution as I had been with binomial and Python in my previous videos. So now I'm going to talk about normal distribution. The formula for normal distribution is 1 over sigma 2 pi e minus 1 by 2 x minus mu by sigma squared. So the x will be from infinity to minus infinity. As we had been with the graph of normal distribution, which is like this, which is from minus infinity to infinity, x is equal to mu here. Okay. So you need to know about its definition as a limiting form of binomial distribution by increasing n. Now we're gonna increase n number of trials to a very large number for a fixed value p. So P will be the success rate will be P, that will be fixed there, and N will be very large. Number of trials will be very large. So this will become as normal distribution. Okay, so there are two parameters in it like mu and sigma. So you need to know about the formula here. So we're going to talk about different terms used here. So mu is actually mean here. You need to know about mu, which is mean, and sigma is like standard deviation. And for pi we know its value, and for e we also know its value. And now we're going to talk about probability density function. Probability density function is like d of x is equal to 1. We were going to prove it out in our derivation in this video. That's very important. So as we have talked about its graph, in which we have talked about two things, in one of them is sigma and one of them is mu. So the graph is like symmetrical and bell-shaped curve. So location and shape of now what is mu and sigma telling us? They will tell us location and shape of normal distribution. Mu will tell us about changes position of normal curve along horizontal axis, and sigma will tell us about horizontal spread, like how much the graph is spreaded, and mu will tell us the position of the curve here, okay, in the graph. So now we're going to talk about the property of normal distribution, which I told you that I'm going to tell you about. We're going to derive it here, which is very famous here, so let's derive it out. Hello guys, property of normal distribution. So the function f of x defining normal distribution is a proper PDF. PDF means proper discrete function, proper definition function. F of x is greater than or equal to 0 and area under the normal curve is unity. It's saying as the f of x will be greater than or equal to 0 and the all the area under the normal curve is known as unity. So we had been with this function as I told you, in which the infinity minus infinity to infinity, as we know about normal distribution, and we're gonna say f of x d of x is equal to 1. So we're gonna take the formula of normal distribution here, which is 1 over sigma 2 pi e raised to power 1 by 2 x minus mu power 2 mu and x dx, not mu, sigma though. So as we know that z is equal to z minus mu, as we know this that z is equal to x minus mu over sigma. We can write z sigma is equal to x minus mu. Then we know these both are as constants. This is constant, and we're gonna take dz is like we're gonna derive a derivation of this. Dz can be written dz, dx can be written dx, and mu is like constant, so it will be 0. So we can take the dz value from here, which is equal to d of x by sigma. Okay, this is we got. As we know, this x minus mu over sigma is equal to z, so we can write it is as z squared. Okay, and it's dx here, so we're gonna write z squared dx, and this 2 will be written as the as 2 here. So as we're gonna do this, now you can see that. And dx, what is dx here? As dx we had been with it, so dx is equal to sigma dz. So we're gonna put all these values in this here. As we have put it, these all values, sigma will be cancelled with this one will be left, and e z squared by 2 with dz is left right now. Okay, so z squared by 2 is equal to like what we can write is a dz z squared over by 2. Let's assume it is equal to y. Now we're gonna say z square is equal to 2y and z is equal to this 2y. Okay, like we're gonna cancel the square root. So let's say uh, this is equal to z is equal to 2y. Okay, so now 2z dz by 2 is equal to dy. Like how we did this, we need to know. We're gonna take it we're gonna multiply it by 2 here, which is gonna give us dz squared, and we're gonna derive it here now. It will be dz is equal to dy over z, which is gonna give us dz is equal to dy over under root 2y. This is uh, the when we will derive it, it will be 2z, because what we call it as 2 will be written as it is, z will be and derivation of dz, and d and 2 will be written as it is. This we're gonna say this whole we're gonna derive. So this is gonna give us this one. Then 2 will be cut with 2, and here the 2 z dz is equal to dy. Our z will be left. Okay, our 2, sorry. So dz is equal to dy our z here. Okay, so this is what we are left with. So dz is equal to dy our, and we have got the z value from here, which is equal to and under root 2y, which is here. Okay, so now we had been with the dz value, so we can put the dz value here as we get dy over under root 2y. Okay, so now I'm gonna say that I don't need this minus infinity. I need 0 here, from 0 to positive infinity, because we will take only positive numbers. So I'm gonna take out under root 2, under root 2 here, and it will be left with under root y, and e minus y dy will be written as it is. But I have the value of dz here, which we had put it as we know. So we're gonna now doing we are gonna do here the stuff which is like we're gonna multiply it with 2 as we know. So this is gonna to be like minus 2, like this is equal to now you have these two here like two square roots. So it will can be written as 1 square root will be 2 multiplied 2 pi, it's here, and the upper 2 is like here as it is, and same all values will be here. It is under root y, which is 1 by 2 up, it will go up, it will be minus 1 by dy, and e minus y will be as it is. Okay, so as all the values are up now and this is all out, we were having 2.2 pi, so there will be 4 in it, and when it will come out it will become 2. So we're going to cancel out 2 by 2, it will give us 1 over pi. This whole is equal to gamma 1 by 2. Okay, this whole is equal to gamma 1 by 2, which is gamma 1 by 2. So gamma 1 by 2 is equal to under root pi. So under root pi will be cancelled under root pi, which is equal to 1, and we have been done with probability of normal distribution. Thank you.